vvvv. You don't hear me?
No.
Okay. What can I do?
No, if you go close to the microphone.
Just like Kyle had this in his mouth already. So again, I need to pull this classic Kyle McDonald. Who has not heard of vvvv? Everyone heard. Oh, this guy. It might be a little bit tough for you than the thing I'm talking about. So it's good to see so many people who have heard of the software we developed. You should also know that, just to recap, we've been doing this for the last 13 years now. We've been developing this visual programming language. And to those of you who have been at our last community meeting in Frankfurt at Node 1 year ago, you should already know that we have started like around 3 years ago in secret. We started to create the whole thing from scratch. Because of course vvvv is great as we know it, but it has some problems and we try to overcome them. We have many ideas which we were not able to just rework the existing code base, and so we decided to start from scratch. And when Philip asked me to talk here about something, and I think this was inspired by this guy in the front, by Edith, I actually looked at the calendar and found out that we haven't talked about this for a while. We showed some of our work 1 year ago, and now it's already 1 year past, and we haven't said a word about it, how we progressed on this. So I thought this might be a nice opportunity to just show you a recent snapshot of what we are working with. This will be the second thing I will be talking about today. First, I want to talk about another random new development we've been doing, and not talking to anybody about it, because it was somehow part of the development of the new vvvv. It's when we were looking for ways to render graphical user interfaces, and we were looking for ways to do this cross-platform, because one of the points when we developed the new vvvv is the idea that it should run on multiple platforms, potentially. So since it's a visually based software, we would have to look for ways to render our user interface potentially on multiple platforms. And when you want to do this as a developer in 2014, you have tons of possibilities and libraries that could create cross-platform user interfaces, but all of them basically stink in a way. They have all a lot of trouble. I know that there will be people that say, use this and this, it's the best. But just in our own research, we found all of the options not very appealing. And so we thought about doing a little bit of an experiment. And the experiment looks like this. So it looks like this would be a timeline, as we would use it often in vvvv, where we have already a timeline, which people don't like because it doesn't have certain features. Like people would always want to have some undos, which we can do here now. Woo! And it's, yeah, again, when we try to do interfaces, our approach is always to think about what can we not have on screen because it's not important. So you hopefully see that this is again a very reduced way of dealing with the timeline, and all of the options you would need when configuring a timeline. You have it on the menu, which is only you get it on middle mouse click here now. You can only add value tracks. We don't have anything other than value tracks for now. But as I said, actually this was only an excuse to do this experiment in user interface programming, because so we thought about what are all the people doing who are developing user interfaces? And one of the things we came up with is that most of the development in user interface design and development in the last 10 years was done on the web, right? And that the platform for the web is the browser. There is a single platform that works on all the other old school platforms that will be Windows and Mac and Linux. And so it's so great that people have kind of come together and built this browser platform, in which they have agreed on some standards, and that would really work across platforms. So we thought, can we do something in a browser? Well, my desktop is really small here, so I lost my icons. So I'm now trying to access the timeline on a local host here. What you see, this is just a Chrome browser here, and in the background is still running the original application. And you see that when I modify either of the timelines, the small real estate, screen estate here, but you see that they both interact directly. And of course, since this is now running in the web browser, this means that this would run on any old school platform via any of the web browsers. And since this is like based on the client server idea now, you can also easily start a new timeline here, and you have multiple timelines easily in the browser in multiple tabs. You can easily have like you would conveniently be able to switch between timelines in the browser. So we thought the browser is both a great windowing environment and a great drawing environment. And you don't have to think about, when you create an application, you don't have to think about how you would work with multiple windows, because the tabbing idea is already really widespread, and it's very intuitive to use for everyone. And you can make bookmarks to the surface of your software and stuff. So we thought this would be a good idea, and I'm just trying to give a little bit of a technical background now how this is done. So the rendering you see, it's all done in SVG, because when drawing in a browser, you have two options basically. You can use Canvas or SVG, or of course you can use WebGL. But SVG has this great advantage that it has a very well-defined, it is a very well-defined standard, and it has like a huge, it's how you call it, the specification is huge, and it can do almost anything you would need for 2D GUI development. And it also has interactivity built in, which is great. Of course, we didn't want to, when we thought about the browser, we said, in the beginning we said, it's shit, because we don't want to program JavaScript. That's not what we want to program in our language, which is C# and .NET, which is super convenient and super beautiful language. And we don't want to, just because we need to write for the platform web, we would have to change the language. So we were a bit scared of the idea of writing JavaScript in the beginning, and then we came up with this idea that actually we wouldn't have to write much JavaScript if we can make it in a way that we would just be able to stream SVG data to the browser. This might sound a little bit off at the moment. So the idea is that we have a JavaScript running, of course, there, but all this JavaScript is doing, it is receiving SVG snippets via a WebSocket and just inserting it in the DOM in the document object model we see rendered in the browser. So this is actually not the technology we invented. There is we call it POSH. That's kind of a more sexy term of pushing SVG to the browser. So this is just a very small JavaScript, what do you call a script? And it just basically receives SVG snippets. So what we can do is we can very conveniently write in our native language, C#, and beautifully use all the language features we have there. And we don't even know about that. In the end, this will be showing in the browser. And so we don't have to deal with the idea of sending things over the network to a WebSocket. This is all handled by POSH as we designed it. So this potentially could be useful for anyone here who needs to write a cross-platform user interface for anything. And we will, of course, soon release this as open source on GitHub. Now there is, I like the idea myself very much, but I have to say we haven't tested it very well when it comes to how far it scales. So we have loaded timelines with multiple of 100 keyframes. And the interaction, as long as you interact with only one or like a group of 10 or 20 keyframes, that's no problem. But if you, for example, then select all of the keyframes at once and want to move them off, what's happening is that there are a lot of SVG snippets being sent via the WebSocket to the browser, and the browser needs to then re-render its whole thing, and then it gets already a bit sloppy. But still, we found it will always be still faster than, or at least as fast as if you do a traditional over the web, like VNC connection to control something. Because of course this could be potentially very interesting if you just want to remote control a timeline somewhere. You have an installation running somewhere, just log in to the web server, type in the URL of the timeline and then modify it. So, I hope this was what I wanted to say regarding this. So this is basically an experiment for now. We will release it soon, and we're not sure how this influences anything regarding the other thing I want to talk about. I said this. Yeah, okay. So that's that was just the first thing I wanted to show. The second thing is a bit of a big thing. For now we call it vvvvv50. So I will be speaking of 45, it's the current version as you know it. We call it vvv45, or the old vvv, and we call it the new one, or 50 or 50, something. Everything you know is wrong is something that we repeat and repeat over the years, just as a joke. But I'm afraid with this new version of vvv, this is really true. It doesn't have much to do with the version of vvv you've been probably working with. This is how it could look like at the moment. We try to keep the look for now a bit close to what we had so far, in order not to freak everyone out too much. So we still have the gray nodes and the pins, and still already you see there are some strange new things happening here, but this is a very simple patch. It's a Pong game. When talking about a visual or any language or a visual programming language in particular, we found it is most easy to talk about it in 4 terms. And the 4 terms would be the language or the development environment. It is a language, it is a library of code, it is a graphical user interface, and it is a runtime. So we'll try now to talk about the new thing we are working on here in terms of those 4 terms, just in the hope that people can follow. The biggest thing would be, which we haven't touched at all yet, is the library. The library in vvv, as you know it, is if you start it up and you start typing in the Node browser, you get, and you have all the add-on packs and packs installed, you get around, I think it is now 2,000 nodes, 2,000 options to choose from. And those are, like, for 90% handwritten by users, contributors, by us, in the last 10 years. And they make up, this is just a guess, but I would say they make easily up like 70% of the actual code base of everything that's involved with vvv. The user interface itself and what you work with. If you leave out all the nodes and the library, I think it's only 30% of the actual code that you work. So you mostly work, of course, with libraries provided by a lot of people, and code created by a lot of people over many years. Which has also, like, code that is created by people has this advantage of being prone to errors, and you find out a bug, after a while someone will fix it and eventually we'll get back, you get a new version of this thing. This is how it worked in vvv so far. Now, this will be very different in vvv50 because we rewrite the whole thing in C#.NET. So we are basing the whole development environment on a library that is called .NET by Microsoft. That is incredibly huge, and it has all the functionality and more that you would usually need, like 90% of your patching things when you're working with lists and XML and all those standard, like, computer tasks you have to work with. They are already there in .NET. And we have a way in v450 to just load the functionality in. So load it in and have it represented as a node. So if there is a function in .NET that does load an XML file and it takes a file name and something, we can say load this function in and represent it as a node which has a pin file name. So this is the, and we have tried this and it works on the test problems, of course. But the thing is that most of the, like, I would easily say 90% of the nodes you see when I would be showing you something here is they are either imported already or they are just patches. So, like, I would say very little of the nodes you will see here are actually written by us in a textual language. They are mostly patches when they are custom, or the rest of the nodes are just imported from the .NET library, which has the big advantage of that nobody has to write them and spend time on them, and they are incredibly tested against, because the .NET library is like years old and is used by millions of people around the world. So we can assume that the code we are importing there is very safe. That was concerning the library. The second point I will have to talk about is the runtime. And you know, in vvv45, the runtime is an interpreted thing, so you're patching around and vvv itself is constantly looking at what you're doing, and like every frame evaluates all the nodes and pins, and then returns the result. This is cool in parts. It's like JavaScript, which is also interpreted at runtime, which has huge advantages, but also with bigger projects it can become slower, because the overhead of the graph and the traversing of the graph and the evaluation could become too big and reduce the overall CPU performance. So with vvvv50 we have started, and when I say we, and you see me sitting here, but you have to understand behind every talking head there is obviously a team of people who are actually doing the work. And this is when I'm talking of the runtime and the compiler, this is specifically the work of Sebastian Gregor and Elias Holzer, who are creating a compiler for visual language. I have no idea how this works, I have to say. But they have it working, and it's a little bit amazing what they're doing there. So what we can actually do here is now, just when you're patching, while you're patching, actually every change you make, the program is compiled instantly, and you see the changes integrated in your running program. And also, in the end, you can just say save as executable and send the executable to someone else who potentially can run it on any platform he likes. Keep it down for now. At this point, I need to point out, maybe you're not aware with the term vaporware. Have you heard of this? I don't have internet, so look it up at home. Vaporware is it's on Wikipedia. They say something like it's software. You call a vaporware software that is constantly being announced and talked about, but never actually reaches the public. So just be critical here. Don't applaud too early. So that was the runtime. The new system is a compiled thing, right? Which would be cool. Third thing was the graphical user interface, the thing you're seeing, you're actually interacting with. There is not much to say about this yet, because we have, for now, as I said, we just made it to look like not too strange yet. And it is very much influenced by the language, actually. So the graphical representation of the patch is very much just a visualization in the best way of the language and its features and its paradigms. So the hope would be that you have a language, and when looking at the graphs and the patches, you would understand intuitively the workings of the program. And so this is very much influenced by the language features, which we haven't finished to design yet. So don't look at the user interface yet as something finished. Brings me to the last point, the language. And here is where I can show you now a little bit. Remember in the vvvv50, as you know it, the language features, now when we're talking about language features in 45 of the current version of vvv, that would be, it is evaluated once per frame. The whole graph is evaluated once per frame. We have spreads. That's a huge language feature there. Actually the biggest, I would say. Another one would be that we have frame delays, the idea of a frame delay, and we have stand receives. Probably this could be counted as a language feature. And yeah, we have the types. Like we have basic value types and like value, string, and color, and then some custom, some more advanced custom types. But this is basically it. This is the features of the language that allow you to express the programs you want to design. And this is not much when you compare it to other traditional textual programming languages. So soon, like for the past years, we tried to sell this, of course, very much. This is the bad thing, spreads, we've invented it, and everyone has to use it. And but we cannot hide from the fact that at some point it's become cumbersome to use, especially with bigger projects. So we had to think about what can we learn from other traditional programming approaches, like the biggest one probably being right now object-oriented programming. It would be so handy if we can really think not only in slices and spreads when we are dealing with particles, but we can actually think in particles. We want to think in objects, and objects usually have data and functions to operate on the data. So the challenge is, how can you transform this idea of object-oriented programming into a visual language? And of course, we are not the first ones to do this. There are projects ranging back tens of years who have tried this before and failed in a way that nobody knows about them. Nobody is using them, or only in very specific niche areas they are being used. So we are trying to bring those ideas, which are there a long time already, into the visual programming language in an area of where people can use it, who do things that we all do. Now, so the first feature I was already talking about would be types. We want types. Looking at the game of Pong here, a game of Pong is very simple. It has two paddles and it has a ball. That's the game. And we can see by looking at the patch that there are two paddles and the ball, as I would expect it from a program. And there is the renderer down here and some input handler up there, which would get me the keypads. Now, looking inside of and when I say type, another word would be, for people to understand, would be class, an object. This would be the inert of the very simple paddle class. And you see here, the first thing I wanted to point out to you is the links have different colors. We have the black links, and we have the white links. And the thing you have to understand here is that everything that's on a white link is the constructor of the class. Everything that's on the black link is in the standard update function of the class. So this would translate to something you would have done in vvvv50 with an on-open. You would have an on-open and a toggle and a switch, and say, when the patch loads, you would only want to do certain parts once, because maybe you read in some large amount of data and you want to make sure this is only done once, or some initialization routine. Already a little bit cumbersome, because you have to use this on-open idea. So here we're introducing the idea of a constructor, which means that this is everything that's on the white wires is only run once the program starts. So for example, here the ball has a speed, and the speed of the ball is initialized to this vector, and this just hangs around here in the patch as if it was not connected to something, but it is connected to this little ball here, and the balls in the patches are setters of fields. Setters and getters of fields. So this is obviously a setter because something is written into it, and this is obviously the corresponding getter function, get function of the speed field. So there is a field, an actual field hiding there, and you can write to a field and you can get the data out of the field. So on starting up the program, this vector is written into the field, and at any time I can use the value in my standard main loop. I can read it, and down here the speed. So the speed is modified here because when it bounces the wall, the vector has to revert, and at the end it's just written again into the field. Now this is actually something which is also very close to the way you have it now in vvvv45, where you would have a frame delay. This is kind of replacing the frame delay. So instead of having another node here and drawing a large wire going back up, the decision was made to hide this fact that there is a frame delay, because we will just understand it intuitively once we know it, that we have fields and we are thinking about actual fields where we can write and read data from. So we have the type which is called ball, and the ball has a constructor and it has fields. Actually there's only one field, data field, which is the speed. And the other, these little quads here, those are still just normal pins as you would expect them. So the ball has input for the paddle. And another field out here which describes if the ball was outside of the area, of the game area or not. Now you see those strange links here. They are state connections, which means that they are actually, so think about it this way, the paddle and the other paddle node sitting here are actual instances of the type paddle. And there is a reference of the instance being handed over to the ball, because the ball needs to do some hit testing to see if it bounces off the paddle. And if we go inside the paddle, we see, inside of the ball, we see that the two paddles come in here. And then what's happening here is that there is a get bounce method. And this is just a method that is being called on, it's a function called on the reference that comes in. So you have an object, paddle, a reference to the object, and you can call a function on the reference. Like you would do in any object-oriented language, you would write my paddle, which is your instance of the paddle, my paddle dot get bounce. And instead of writing dot get bounce, we do a link here and call another node. And where and who and how is this function represented? I right-click on the function, jump to it. So jump to the paddle, where I would assume that the function is somewhere visible. Can't find it. Doesn't look like it is here. But look closer. We have just two output pins here, and the output pins are in a different color. And if I hover with the mouse, I see it's written vector 2 on get bounce. Get bounce is the function. So when the function is called somewhere else, because the reference goes down the patch and someone calls the function get bounce, what happens is that patch comes back here and sees, okay, this is a very simple function. I only have to return the position and the size. And you see this little experiment here, which tells us that here is actually the boundary of the function. And in between the update function, which I was referring to earlier, everything that is black is on update, on the update function, and everything in a different color is on a different function. In between those two functions, there is a field. So So I said every field is represented by a circle. And you see here that the black function writes in a field, and the orange function reads from the field. This is just, in the beginning we had this just as a straight line, but then we thought we could even visualize these anonymous fields that are being created here, because it gives you a better sense of where the boundaries are between the functions. So usually you can really compare this to a standard object-oriented textual programming language where you have your class definitions and function definitions and field definitions. But usually you have them in code blocks and strictly laid out under each other. But here in this 2D arrangement possibilities of a patch, we can just throw them all in one game of Pong that is implemented here. I'll wait here. Yeah. It works. Okay, just stopping this and going on with the next language feature I wanted to talk to you about. Another crazy one, generics. Let me start this example. This, okay, I first have to show you what it does. Nope. How did I do this before? Ah!
Maybe this key left. So if you go into the window and then
yeah.
you this key left, you can move it across. And one is down.
Down?
We have to click it.
Yeah, and now I can. Alright, that's. Okay, so this is a very simple queue example. But it is very interesting what's happening here once you know what it is. So I'll leave it like this. But before I quickly wanted to point out the idea of the generics, and people who know the word generics will know what I mean. So here there is no queue in the .NET library, or at least I'm sure there is, but we didn't find it quickly. So we thought we can quickly patch a queue. And this is how the queue looks, and if you look closely, you see that the item has another special key link here, and it says that the item that's coming in is not typed yet. So the idea is that the queue we patched here is actually a generic queue taking in any kinds of object. You can queue particles, you can queue values, you can queue strings, and this is like in vvvv50 we had to write a single queue for every data type in the beginning. Then we had the plugin interface, and it was already able to do generics like this. But here you see this is all the queue needs. This is a very simple patch. I think it's very readable. You have state in and out, and if you hover it, you see the state is just the list of items, and it has like 3 functions here. You can clear the list, like you can reset the queue, you can add a generic item to it on insert, and you can take, this is an take last. What does it actually do? It takes the last count items of the list and returns them, always leaving out like a queue. It's running and it leaves out the oldest one. So this function would only take the newest 5 and leaving out the last one. And then again writing it to the list, and in the next iteration you would have the new list. Very simple. And here is the output. You get the output. So this patch of the looks like this as a node with the inputs. And so this was language feature generic. Now next language feature, events. Very useful for things like input devices, and vvv is very big with allowing users to use any kind of input devices, but it is also very limited in a way that all the input devices would always be only synced to the main loop. So if you have a device running at 100 frames per second, but your patch only runs at 50 frames per second, what's happening is that right now we would just discard all the data that's too much for it. And there are special nodes like the MIDI nodes. There you have an option to choose the buffer size, or with the UDP nodes you have a buffer option, but then you cannot really do anything. Like it's hard to deal with the buffer data then. And here we have events now, which means that we can react to incoming data at different rates. So and here this demo shows this, the mouse comes in at a much higher rate than the main loop of the program right now. So you see I was drawing two trails here, the orange one and the blue one. The blue one is the one that is bound to the main loop, and the orange one is the one where we insert the data into the queue as it comes in. So we are queuing up the data when it comes in and only draw it when we can draw it. But the number of frames of drawing is still limited, but we're not missing any of the data that's coming from the mouse. You see that the orange one is much closer together and much more detailed because it's representing the actual data. And the blue one leaves a much longer trail and much jittery more one, because it's limited to the main loop's iterations. So, and how does it work? So in a traditional way, this is how you would expect it from the vvvv50. Just assume here you have the mouse node. Here it's called the mouse state, and the mouse node just returns the position as a vector 2D and the left mouse button, and then you just pipe this data into the queue. This is how it was done so far. And the queue, the result of the queue is just a list of positions, and it's rendered with the rectangle here. Now the second option, using events, looks a little bit more complicated, of course, already. So here we are not receiving the mouse state, but the mouse event. And whoever is familiar with the terms of observables in .NET programming, this is what's being used here. We can subscribe to the observable that gives us the drag data, and then the drag notification comes in here. We can split the notification drag because it has some more info. It has the position and I don't know what else. The drag has the position and the delta of the last movement between the last position and now. So anyway, we split this, and this is a strange construct here. This is just called update right now, but if you see on the tooltip, you see it's actually the update function of the queue. And the queue is created here. This is very silly that we just call this create and this update. And actually you will want to see the name queue here, of course. There is a queue created at some point in the constructor, and then we are calling the update function to insert items into the queue. And we are doing this in a rate that the notifications come in, actually. And then we are writing the queue into a field, and the position field is read out here. And again, this is a list of vectors, which is just drawn as reference. So that was the language feature of events. And do I have one more? Yes, this is one we were showing already at the node, the loops. So, worms. The idea of loops. So I'm afraid, as it stands now, the idea of spreads are kind of dead. So whoever tried to bend his mind around spreads, you just wait another 2 years or so when you get this, and you don't need it anymore, probably. So this is the game of worms. Let's start it again. Click. Yep. You all know this game of worms, I guess.
It's called tanks.
Hmm?
Isn't it called tanks?
We did some research on this, and there is originally this is in the realm of strategy, like shooting games. There is a large article on Wikipedia about it, and worms actually it came later, but it is in the same idea. And I don't know my keyboard assignments here yet, but so I can. I have this worm and can position it and then shoot around here, and then the other worm shoots, and I have to hit yes, like this. So, and what I wanted to point out is here we're creating a terrain of those little quads here, and this is done by several loops, which I wanted to show you here. Now, just an overview. This is the game of worms. Here we have the terrain, creation of the terrain. We have the shooting worm, one shooting worm, another shooting worm, and just some flip-flop that switches between the two players. So let's go into the terrain here. And here we see the loops in operation. So the terrain is created in a way that you see here it says we are first going through a loop of 9 iterations where we are randomly creating points, which would be this would be the first point, second point, third point, fourth, fifth, sixth, seventh, eighth, ninth point. So we're initially creating a rough outline of the terrain, which is stored in the list of 9. It's just float values here because we only need the height, and the width is spread out evenly. And then we have a resample node which takes in a list and resamples it to a linearly resamples the list, like it's a resample spread. It's the same idea. So basically all the list, the spread operations as we have them in vvvv can be thought of and repatched as a list operations, of course. And it's incredible how many of those functions are already available as .NET functions anyway, which we can just borrow. So this would be the implementation of a linear resample. But back to the loops. Here we just get out another loop, another list which has more positions already in them. And we go through another loop now, which creates us, for each of the points we got interpolated, we create a column of actual terrain cells. So here there is a loop, and it calls the function build cell column, which is just here in the terrain helpers, which again just creates going through another loop number of quads that will be stacked for each column in the terrain. And then in the end we have a list which is a multi-dimensional list of a list of lists of columns in the terrain. And we flatten this list because the columns would no longer be interesting for us later when we do the hit testing. We just need a list of coordinates of all the terrain cells. So here we have a list of cells, which we're adding to, and just in another part of the patch, which seems totally unrelated, but is of course connected via the cells field, we can do the hit testing. So we say, return us all the cells where the getIsHit function returns not true, and all the others would fall out. And you see here the words like where and select, and those are all people who might be familiar with it. It's a representation of the link functions that are available in .NET. So if you're familiar with link programming in C#, you can do this now in a visual way here, which is extremely powerful and interesting to learn, really. The looping was the other language feature I wanted to point out, and there is one more, which is a bit hard to everyone knows it, everyone has heard of interfaces. If you want to define an interface instead of a class with specific properties, you first design an interface, and then multiple classes can implement an interface. And then you have, for example, an interface called shape, and the shape has a position and a bounding box, and you can implement the interface shape by a class called box. Let's say quad, and another one called sphere, circle. Right? And then you can have a list of shapes, and you don't have to be specific about the type the list holds, because it only holds shapes. But a shape could be a circle or a square. So it's a very convenient way of abstracting using those interfaces. And we don't have a very good example yet of those interfaces in use. We are using them here, of course, already, because here you see the renderer. It takes what it takes on its input is iRenderable. So it takes a list of interfaces of objects that implement the interface iRenderable. This, in our case, is we've only implemented this once with the rectangle. We haven't done any other graphical representations yet. So at some point in our graph, there should be rectangles hidden. And if here are the rectangles in the worm. And if I open the rectangle, you see that it's implementing the interface iRenderable, which has which has only one function, I think, and the function is called render. And whenever an object that implements the interface iRenderable gets called the function render, it receives two inputs, and the inputs is the graphics context and the client size, as we chose now. And then, so this is how the implementation of an interface looks like. It's basically an interface is a collection of functions, and we are just implementing a function of the interface here. And so you cannot really in visually yet distinguish between functions and interfaces, functions of interfaces. We would at some point have to make visualize this that you can see, okay, this function belongs to an interface, which is not always important to know, but it helps, of course, in reading that. So this is basically the last language feature we have for now. To recap, we have types with constructors, fields, and methods. We have the generics. We have events in terms of observables. We have loops. For now, we only have the for loop, but you can easily think of for each loops and different kinds of loops. And we have the interfaces. think basically this is what I wanted to share at this moment. I guess there are no questions left, so are there?
Let me just preface this by saying that I've not done anything actually with vvv, and I'm still thinking about flat chat from the previous presentation. But you said that you're trying to interpret everything as an object-oriented thing. Why would that be good? I mean, obviously it doesn't fit everywhere.
Yeah.
These interfaces are a great example. For me, it's the most interesting thing here, because it's sort of stepping out of the comfort zone. But then immediately you can't represent it in an object-oriented way, so why would that even be a goal for you?
No, so I didn't say that we're trying to represent everything in an object-oriented way. This the idea is still to take the best of data flow and combine it with the best of functional and object-oriented programming. So all the features I was referring to now, they come from a world of object orientation, but you still see, I didn't mention all the stuff that we still kept from the old version, which is a traditional data flow, which makes patches readable once you get into the idea of data flow. But why would this be usable? Because we've been developing a software for the last 30 years and we hit boundaries, and we thought about how can we work around those boundaries, and not only work around them as we do in the last 13 years using spreads and bin sizes and vector sizes, but actually just borrow paradigms that work in other worlds already and try to implement them here. So the idea would be that we're trying to offer more paradigms of expressing when writing a program. We were very limited in language expression features before. Now we're trying to implement more ways a programmer, a patcher can express himself when patching. And like a language has ways to express ideas. And that would be the now if you're thinking, oh man, this sounds so and looks so complicated. I would put it differently. I would say, if someone says, will this be more difficult to learn? You should not, and maybe you can, Kyle, can you put this in a tweet? Like, I can't think of it in 140 characters right now, but maybe you can shorten this. So the idea would be, is this more difficult to learn? No. There is just more you can learn about it. Right? There is just more features, so you can learn more about it. You can still use the same thing without all the features, and it will feel like what you had so far, except the spreads.
Which you could implement as an object anyway.
Yeah. Someone could build a library of nodes that behave exactly like the ones we had right now. But we thought hopefully nobody will really do this now. It would be a kind of a step backward, but it's totally doable.
So right now it seems that the patch is a class.
Yeah, you can say it like this.
Yes, but you mix nodes which are classes and nodes which are functions in 4 or 5 sense, and kind of seems weird a bit.
We consider the what would be a classic. The worm is a type, is a class, right? And then of course inside of a worm you can instantiate a gun, because the worm has a gun, and the gun would be a totally separate object, which it's totally separate patch, which defines the type gun. But then the worm would, inside of his patch, create an instance of the gun. So of course there is a mix between, it's not a mix, it's a kind of cascading of objects. Objects can have fields of other objects and instances, and access them and run functions on them.
And also you showed like 2 worms. At least in the Pong game there are 2